Hello, algebra students. It's Mrs. Thompson. We are getting ready to jump into Chapter 9 on exponential functions, Section 2, and we're going to look at Example 1, evaluating an exponential function. So what's important here is to remember that exponential functions have a common ratio on the y. The x's we expect to go up incrementally, and then the y's we're expecting to find a ratio. What I mean by that is, what are you multiplying by to get to the next y? And that should be consistent and constant. So for example, as you look at this particular chart, we see that the x's are all going up by ones, okay? 0 to 1 is 1, 1 to 2, we're going up by 1, 2 to 3, we're going up by 1. So that's a constant increasing, I guess, is a great way to say that. On the population side, what we're looking for is a multiplicative increase, okay? Now that increase could be by a whole number, it could be by a fraction. So when we go from 2 to 6, we're multiplying by 3. 6 to 18, we're multiplying by 3. And 18 to 54, again, we're multiplying by 3. This is called a common ratio. Remember, in linear, we had common differences, but with exponential, this is a common ratio. Okay, I'll write that out for you. So here on the next line, we're going to see this is the very, very basic exponential function, a times b raised to the x power, and only b is being raised to an exponent. A is not. A is your starting population, or the beginning amount. B is your common ratio. So what are you increasing by on the y side? Multiplicatively. And x is the time increment, or how many times it occurs. Okay? So let's look at example 1. The function f of x is equal to 2 times 3 to the x power, and that models an insect population after x days. What will be the population on the 5th day? So as you break this down, 2 is your starting population. You're starting with 2 insects. The 3 is the common ratio. That just means that the population is tripling every day. And then x tells you in the problem, that's number of days. So that what they want us to do is they want us to take this information, the 5th day, what's the population on the 5th day, and they want us to insert that right here for x. So here's where you're going to grab your calculator and you're going to plug in 2 times 3 raised to the 5th power. And you might have to use that roof button. Let me draw that out for you. 2 times 3 raised to the 5th power. That's how it should look on your calculator if you're using one of the TI-83s. On the TI-84, it actually will show up when you hit the roof button. It will bring that exponent right up to the top. That's what it did on my calculator. So once you get that in there, press enter, and your population should be 486 insects on the 5th day. This is exponential growth. When things are tripling, you're going to increase that population much faster exponentially than you would linearly. Okay? So let's look at letter B together. So they give us f of x is 1500 times 0.995. Now notice that the 0.995, that's your common ratio, but it's not a number that's bigger than 1. Any numbers bigger than 1 would indicate that the population is going to get bigger. If that number is a decimal and it's less than 1, then this population is shrinking. It's not growing. So x is the time in years that it's modeling a prairie dog population, tracking it over a series of years. So how many prairie dogs will there be in 8 years? Now we are expecting that if we're starting with 1,500 prairie dogs and the population is increasing 0.995, and that means it's actually not increasing, it's decreasing because it's a number less than 1, we're going to see, well, what happens to this population after 8 years? It tells us X is time in years. They give us 8 years. That's what we plug in. So I'm expecting a number less than 1,500 because the population is actually not growing. So here's where you're going to grab your calculator, plug in 1,500 times 0.995 raised to the 8th power, and you're going to see that you're going to get a decimal. Now you cannot have 0.039565 of a prairie dog. That's impossible. You either have a prairie dog or you don't. So we're going to do a couple of squiggles here because we're going to approximate that the population is going to fall, and we're going to round that to 1,441 prairie dogs. So we don't want a decimal here because that would imply that you can have part of a prairie dog. You can't. It's got to be a whole number because you either have a prairie dog or you don't. There's no in between, okay? I'm going to leave this next one for you guys. Read it, solve it. This will be your extra credit for this video. Write it on your paper, and then, of course, please remind me that I said that this is extra credit because I will probably forget. All right, that's it for example 1. Write down any questions you may have. Great job.